Good morning, dear class minus. Today we will discuss with another topic, that is a barometer, that is instrument to measure atmospheric pressure. So we are dealing with the term atmospheric pressure, the definition as well as the consequences. The two consequences I have explained you about the atmospheric pressure. Now today we will deal with the instrument to measure atmospheric pressure. So barometer is an instrument to measure atmospheric pressure. So there are three types of barometer. One is a simple barometer, other one is the 14th barometer and aneroid barometer. Now the simple barometer was designed by Torresel in 1643. Okay, it was designed by Torresel in 1643. Now this barometer consists of a liquid, and that liquid is mercury. So mercury is taken as a barometric liquid. So inside that instrument, inside the barometer, okay, it is filled with a liquid which we call it as a barometric liquid, and that liquid is mercury. Now let us come to the barometer, that is a simple barometer. Now this simple barometer, it consists of a glass tube, 1 meter long. Okay, it is a 1 meter long glass tube. One end is open, another end closed. Okay, same like a test tube. Okay, a thing over the test tube. So the test tube also one side is open and other side is closed. And this tube, which is 1 meter long, it is a glass tube and it is filled with completely filled with mercury. So that is, this is the tube here. It is completely filled with mercury. And we take a trough. A trough means a container. Okay, and this trough is again filled with it contains mercury. And the mercury is filled in a glass tube also, as well as in a trough also. Now, what happens is, now this tube, in this tube you fill a mercury and you make it tilted upside down. So then you make it inverted. So when you fill, before that, when you fill the mercury in this tube, the care should be taken so that there should be no any air bubbles inside the tube. There should be no air. So the air has to be removed. Okay. Now after filling the mercury inside the tube, this tube are tilted. That means these are made inverted like this. Okay. And when you make inverted, the open end of the tube is closed with your thumb. Okay, and this process you do it, that means you keep on tilting the tube upside down so that any air which are present inside the tube may be forced out or removed out. Okay, then after that, this tube is kept inverted. Okay, and the inverted tube is placed in a trough containing mercury. Okay, so that means it should be placed inside a mercury. And once the tube is placed inside the trough containing mercury, the care should be taken that immediately you remove the thumb. You remove your thumb from the open end. Okay, and after that, what will happen is that now this tube is immersed inside in a mercury, in a trough which contains mercury. Then after that, what will happen is that now the level of the mercury, it falls. Okay, the level of the mercury, it falls, and it falls in such a way so that the height of the mercury remains at 76 centimeter or 0.76 meter. 76 centimeter or 0.76 meter or 760 millimeter. Okay, so these are the unit. So now this level of the mercury, it falls, okay, in this tube. Okay, and how it falls is that the mercury will not fall completely. It falls in such a way so that the height of the mercury level in the tube remains at 76 centimeter. So this 76 centimeter is the atmospheric pressure. Okay, atmospheric pressure at a sea level. And when the mercury will fall here, and here it creates some vacuum here, some empty space, because the mercury has fallen down. okay, and it falls from the tube and collected in the trough here, and it creates a vacuum here, and this vacuum is known as the torsional vacuum. Okay, this vacuum is known as a torsional vacuum, and therefore what will happen? This height A and B, this height will give the height of the mercury level, and this height will be the atmospheric pressure, which is given as 76 centimeter or 0.76 meter or 760 millimeter of mercury. So this is how the simple barometer, this is the construction of the simple barometer. Okay, now the next point will come to the atmospheric pressure. Now what happens that now this tube is placed in a trough. Now the atmospheric pressure will act on all the sides of the tube. Okay, atmospheric pressure will explanation of this how this only the how it is designed. Okay, how it is kept. Now next one is the explanation of this barometer. The second point is there. Now the atmospheric pressure act on all the sides of the tube as well as on the surface of the trough also. Okay, on the surface of the mercury. That means the atmospheric pressure will exert on the outside the tube also as well as on the surface of the trough. Now, what happens is that the pressure at the point A is the pressure at the point A, that is this point A, is due to the weight of the mercury column. Okay, the pressure is due to the pressure also exerted here. Okay, and this pressure exerted at the point A of this tube, of this barometric tube, is due to the weight of the mercury. Okay, that means the pressure will exert outside the glass tube also. Okay, as well as on the surface of the trough. Okay, as well as at the point A also the pressure will be exerted, and this pressure is exerted due to the thrust or due to the weight of the mercury column. Okay, then the next point is here. Now the mercury level. Now what happens is that now this mercury level falls, and after that it becomes stationary. Okay. The mercury level falls, and after that, after falling, after some amount of mercury falls, then it remains stationary. And when the mercury will fall, the vacuum will be created. So after that, when the mercury falls, the level of the mercury will remain stationary. Stationary means it will not fall; it remains at rest. That means the mercury will not fall at all. When the mercury level in the tube becomes stationary, then the pressure inside the tube, A, and at the surface of the trough C will remain same. So when the mercury will remain stationary, but before that the mercury will fall because the pressure is not same. The pressure is not same. So when the pressure is maintained, equal pressure is maintained at the point A and in the trough, that is at the point C, then the mercury level will remain stationary. Okay. Then after that, the vertical height of this mercury column, and when it falls, and this vertical height of the mercury column will give the atmospheric pressure. Okay, so this will be the atmospheric pressure. So the level of the mercury will fall, and why it falls is there because the pressure is not same before. The pressure at the point A and point C is not same. So that is why the level of the mercury falls and it creates a vacuum. Then after that, what will happen? The pressure is exerted outside the tube also and on the surface of the mercury in a trough. So when the pressure at the point A and point C will become equal. So at the point A, the pressure is exerted because of the weight of the mercury, and at the point C, the pressure, that is atmospheric pressure, is exerted. So that means pressure is exerted both at A as well as at C. So when the pressure becomes same or equal at point A and C, then the mercury level will remain stationary. And that when the mercury level is stationary, then the height of that mercury, that is x is the height. So this height A and B will give the the level of the mercury, and which gives the atmospheric pressure. Okay, at a particular place. So if the atmospheric pressure increases, again what will happen? If the atmospheric pressure increases, the pressure at the point C will increase. If the atmospheric pressure increases, the pressure at the point C will increases. That means that due to the increase in the atmospheric pressure, the pressure at the point C means the pressure on the surface on the surface of this trough will increase, and when they will increase, therefore the height of this mercury column will also it rise. Okay, when the atmospheric pressure increases, then the pressure at the point C will also increase, and therefore the level of or the height of the mercury it increases. Then when the atmospheric pressure decreases, okay, the pressure at the point C will also decrease, and when it decrease, then what will happen? The level of the mercury will also it falls. So therefore, this level of the mercury it falls or increase depending upon the increase or decrease of atmospheric pressure. Okay, but when the mercury levels, when the level of mercury, when the height of the mercury comes at 76 centimeter, so that 76 centimeter is the height of the mercury column, or that denotes the atmospheric pressure or normal atmospheric pressure at sea level. Okay, so this is how the simple barometer it works.